In this video, I'd like to talk about finding the distance between 2 points on the coordinate plane. So we have these 2 points and we need to figure out how far apart they are. So let's first start by just labeling these points. Notice the x value here is 4 and its y value is 6. Write the x value first. The x value for this point is at -5 and its y value is at 8. Let me rewrite that. And to find the distance between these points, let's start by drawing a line between the 2 points. And essentially, we just need to figure out how long is this line? What is the length of this line? And we can call that this distance, we can call it d. And the strategy to figure this out is that we can essentially make a right triangle using these coordinate points and this line here, this distance. So if we draw a line straight down, and we're just going to go down 2 units since we want to match up with the y value of our other point. So let me use the line tool again for that. So we're just going to draw straight down 2 units, and then we're just going to go straight over to our other coordinate point. And notice that with this triangle, this is a right triangle. So this is a triangle with a 90-degree angle here. And with right triangles, we can use the Pythagorean theorem to figure out the relationship between the side lengths. So we need to figure out how long these two sides are. And from that, we can figure out how long this distance is between the 2 points. So notice that this side length here has a length of 2. We were at a y value of 6, where the bottom of this is, and we finish at a y value of 8. So really this was 8 minus 6 if you want to find that difference. And for our x values here, this bottom side of our triangle, notice that we start at an x value of -5 and we go to an x value of 4. So if you want, you can just count this. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it looks to be 9 units long. Or we could follow the same strategy. We can find the difference. So start with your higher x value and subtract your lower x value. So 4 minus, this is a -5, which is really just 4 plus 5, but that's 9. And that matches up with what we counted. We found, just by counting, that this is 9 units long. So we have this right triangle. Let me redraw this right triangle so that we can focus on it outside of the coordinate plane. So with this redrawn right triangle, we can focus on it a little bit better. And again, this is a right triangle. It has a 90-degree angle here. And because of that, we can use what's known as the Pythagorean Theorem, which, like I mentioned, just relates the sides in a right triangle. Specifically, if we write it mathematically, it's written as a squared plus b squared is equal to c squared when we have, let's say, some random right triangle where the legs of the triangle are a and b, and the long side of the triangle, the hypotenuse, is length c. So we want to use this theorem to figure out what this missing side length is, what d is equal to. So basically, we just need to match up our side lengths to the formula here. And the key idea is that the two legs of the triangle can be labeled as either A or B. That doesn't really matter. So we can call this one A and this one we can call B. But what does matter is that the side opposite the right angle, this hypotenuse here, this has to be called C. And remember, C is the one by itself on the other side of the equation. So now that we've labeled everything, we can just plug them into our formula here. So A, we called that 9, so we have 9 squared, plus B squared, that's 2 squared, and this is equal to C squared. And C, that's our distance here. So that's equal to the distance squared. And at this point, we just simplify. So 9 squared, 9 times 9, that is 81. 2 squared is 2 times 2, which is 4. And this is equal to d squared. Now, 81 plus 4, that's just 85. And this is equal to our distance squared. So we need to get rid of this square. And remember, to cancel out a square, we can take a square root. So we can take the square root of each side, since squaring and square roots, those are inverse or opposite operations. They cancel each other. It's like multiplying a number by 5 and then dividing that number by 5. The multiplication and division, since you use the same number, those will cancel each other and you just get back what you started with. So that's the same thing with squaring and square roots. So this right-hand side, this is just d. And the left-hand side, this is the square root of 85. Now, the square root of 85, you can ask yourself what number multiplied by itself gives you 85. But it's not going to be a whole number answer. Since if we look at this square root and we compare it to others that we can actually find an answer for. So let's say the square root of 81, that is less than root 85, and the square root of 100. So square root of 81, that's just 9, and the square root of 85 is between that, and the square root of 100 is 10. So this is somewhere between 9 and 10. And in fact, it's going to be what we call an irrational number. I'll use the pound sign for number here. And an irrational number, remember, has an infinitely long decimal expansion. So if you put this into your calculator, you can get a rough idea of what its decimal expansion looks like, since the calculator has to round it at some point. So this is 9.2195, and this is going to go on forever. There is no pattern in the decimal here. So that's what happens when you have these irrational numbers. And most square roots are going to be irrational unless you have a perfect square, some number that when you do take its square root, you get a whole number. So our distance between these 2 points we found is the square root of 85. So d is root 85, and you could write it as a decimal, but be careful with that, because when you write it as a decimal, you have to approximate it at some point. So maybe we could write this as about 9.22, but it's not exactly equal to this. So if you're looking for an exact answer, you have to leave it as a square root.